to us. We thank you that we could be here this morning and learn more about you and the creative ways that you've communicated since the beginning of time. And we appreciate that so much. And may it warm our hearts this morning, we pray. In Jesus' name, amen.
We have a few moving parts this morning, so whoops. Here. We stayed at a hotel, so that meant packing up. So it took a little longer. Okay. That's right. And I'm going to stand up here so you can all see me. How's that? Okay, do the math. So, do the math. 3 plus 1 equals FOR. And I know what you're all thinking. She misspelled 4. Oh, my word. And it's on math. But I didn't. And you'll see at the end. This will come full circle and you'll see. So the big question, were mathematics invented or discovered by man? If they were invented, then we actually made the language of the universe. And that puts us in a pretty high position. But if they were discovered, we have to acknowledge the intelligence that made that language. So why did we even begin to use math? And this, I'm going to quote mathematicians that are both believers and non-believers. This man is Marcus de Sautoy. He is a professor of mathematics at Oxford University, and he's the Simone, which means he is the public face of science. So he teaches the world through TED Talks and presentations. So this is what he said. Our world is made up of patterns and sequences. One of the reasons mathematics began was because we needed to find a way of making sense of these natural patterns, right? We've got the phases of the moon. We've got seasons where we have plants growing. They blossom, they seed, they die. We have migratory going by and all around us. So early man saw this and thought, okay, what's the difference? And plus we had to, there was trade going on, right? The silk trade was in BC. And so how are you counting out money, or how are you bartering fairly? So most basic concepts of math, space, and quantity are actually hardwired into our brains, which I was really sad to hear this, because I used to say, well, I don't have a math brain. So that's why I couldn't understand math. But actually, I had no excuse. Our brains are hardwired. Even animals have a sense of distance and number, assessing when their pack is outnumbered. So that tells me dogs can count. Now, I know we all think our pets are brilliant, right? But, it's saying wolf packs and predators they understand, I have less on this side than you have on that side, so I'm going to back down. And I had never thought of that. And whether they should fight or fly, and whether their prey is within striking distance. Now, we think of reptiles like a snake, not a lot going on in that brain, but yet they can do the math. They can see if their prey is within striking distance, because otherwise they're not going to waste their time. I never thought that was that much going on in their little brains. So where did mathematics originate? Now, for me, this was a surprise. But then when you think about it, it really isn't. Oh, can we turn off our cell phones? Yeah, and even if you can you check to make sure they're on vibration? Because I have to memorize a lot of facts, and that's going to throw me. So the earth was without form and void, and darkness was upon the face of the deep, and the Spirit of God moved upon the face of the waters. We have read this verse. So now we have, we're going to break it down. So we have water molecules without order, recognizable shape or observability, right? None of us observe this. And there's no shape, it's a blob, it's shapeless, there's no order. So I'm going to take that same verse about the Genesis 1:2, I'm going to put some of the original Hebrew words into it. The earth was confusion, a place of chaos and empty, and dark obscurity was upon the surface of an abyss of surging water. Wow, that's a different image, isn't it? So we looked at this verse last night. This is in Job, and God is asking Job, where were you when I laid the foundations of the earth? Who determined its measurements, or who stretched a line upon it? He's saying that he used math, because stretching a line is determining a parameter, right? I'm determining the measurements. This is math. So God is going to use math to change that chaos into order. Unknown into recognizable patterns. And obscurity into predictable sequence of evenings and mornings, which we call time. He used math, the language, of course, that he thinks in math. He used it to change. I love that, chaos into order. And when we look at that, we've been in chaos. We face the unknown. We have felt obscure. And he can bring that balance and order and logic into our lives. So is he a God of math? Well, it turns out he loves math. But the very hairs of your head are numbered. I know until we start losing our hair, right? Do we care how many hairs are on our head? I really don't need to know that number. Does he not see my ways and count all my steps? Does that mean something? Oh, okay. My what? Oh, okay. Does he not see my ways and count all my steps? Since his days are determined, the number of his months is with you. So he knows our days. And I love this. You number my wanderings. That word, not wanderings, that word is used only once in all of Scripture, and it means aimless fugitive. You number the times I have been an aimless fugitive. The times I have left you, Lord. I have lost direction. I've lost my way. Maybe I've outright become a prodigal and rejected you. You have not forgotten any one of those. You number them, and you put my tears into your bottle. He cares about every time, really everything we have done. Okay, there is scanning, tunneling microscopes. We can now see atoms. And here's a verse that says, he is before all things, and in him all things hold together. He holds the bonds of atoms, and when we now see it through a microscope, we find order. You can see iron atoms on copper, and then the other one is a nickel. That flat, smooth nickel we hold, that's what it looks like. And the atoms are perfectly lined up. There is order and there's patterns. So when did humans begin to use mathematics? Then God, brought Abram, this is 1900 BC, he's outside and said, look now toward heaven and count the stars if you are able to number them. He's telling Abram to count. Do you know this is the first time God told any human to count? But why Abram? Did he just look down there going, to ask his angels, well, who's standing around down there? I've got a task for them. No, God doesn't do random. So count and number is the word safar, which is where we get our word cipher from. So safar means to score with a mark as a tally or record, to enumerate, to inscribe. Abram was the first to be told by God to physically inscribe, tally, record the number of stars, but why him? Okay, where did Abram grow up? Ur of the Chaldeans, right? And the Chaldeans are actually, that's Babylon. The Chaldeans, in fact, I think it was Ur or the Chaldees, that was like the jewel of Babylon. So it's Babylon. Ancient culture, but very advanced. We think of Egypt as being advanced, and they were, but Babylon, way ahead of Egypt. Here's Plimpton 322 clay tablet, reveals the Babylonians understood geometry, algebra, trigonometry, which is study of, uses triangles, and fractions. And this is way ahead of the Greeks. 400 clay tablets reveal Babylonian math remained constant for 2,000 years and was superior to Egypt's. Plimpton 322 proves they used trigonometry 1,000 years before Hipparchus. He's a Greek mathematician that's called the father of trigonometry. He wasn't. The Babylonians were. God did not randomly ask any human to count stars. There was a reason it was Abram, because he could literally do the math. He grew up in that culture. They knew how to do the math. And when you're counting stars, you're dividing the sky into certain sections. You count each section and you figure out, you multiply. I mean, you can do it. He could do it. So God has purpose behind his plan. When he asks us, he's enabled us. And here Abram could do the math. So how did the founders of modern science view math? And what's interesting is modern science was founded on believers, right? All of the early scientists were believers, and the whole reason they studied creation because they believed in the Creator. They knew they would find the laws of nature. There would be logic in there. Also, natural selection, scientific method, both developed by creationists. All right, here's Pythagoras. There is geometry in the humming of the strings. And if we have musicians here, you know there's math in the music. He's saying there is math in the music. And here's the Pythagoras ratios for guitar frets. I'm not musical, but there it is. For those of you who are musical, you understand. But here's what's even more amazing. Pythagoras said, and this is 5th century, 500 BC, he's saying there's math in the music and there's music in the math. And as an example, he says there's music in the spacing of the spheres. The telescope would not be invented for a long time. And here he is saying he's right. How did he know there was a mathematical pattern in our solar system? There's actually a mathematical formula for how far away each planet is from the sun. He only could have known this if the maker of math and the maker of the solar system told him. We're made in his image, and that's why we can understand the language of God, because we are made in his image. Okay, mathematics is the language in which God, this is Galileo, it's the language in which God has written the universe. Galileo totally understood. Here he is, he's saying it, here's what the language is. And he was an astronomer, a physicist, and a mathematician. Boy, today we typically major in one thing. And some of these guys, it's amazing, their education level. He said, it is written in mathematical language, and the letters are triangles, circles, and other geometrical figures, without which means it is humanly impossible to comprehend a single word. If we don't look at the language of God, we're not going to understand it, because we need to know that math. Here's Kepler. Geometry is one in eternal shining in the mind of God. He's understanding it's the language of God. That sharing it, according to men, is one of the reasons that man is the image of God. It proves it, because we understand his language. Here's Isaac Newton. All variety of created objects which represent order and life in the universe could happen only by the willful reasoning of its original creator. And Isaac Newton was amazing. I mean, they all were amazing. But they're all saying they're seeing God in his creation. And I remember John Lennox, he's Irish, also a mathematic professor at Oxford. And he said, he debates the atheists, and he said, well, when Isaac Newton discovered gravity, he didn't say, oh, well, now I don't need God anymore. Instead, he's like, wow, how clever, how he made gravity so clever. In other words, he still credited the creator for doing that, instead of, oh, since I discovered it, I don't need him anymore. It was always within the context of the creator. So is there a connection between math and the arts? So here's, this is G.H. Hardy, mathematician, wrote a book called The Mathematician's Apology. He said the mathematician's patterns, like the painters or the poets, must be beautiful. Now, I have never seen math as beautiful. He's saying the ideas, like the colors of the words, must fit together in a harmonious way. He's saying there is art and beauty in math. Here's Arthur Benjamin. Math is used to learn calculation, application, and inspiration. Now, Arthur Benjamin, the first time I did this presentation was at Pastor Don's church in San Juan's. And you had a family there visiting from somewhere back east, I think, and their kids got so excited when I showed Arthur Benjamin, because they watch his TED Talks and his YouTube. He teaches kids how to do math in their heads, and he makes it fun. So they love it. He's completely changing how we see math. And here he's saying it's a much bigger picture. It's so much more a part of our lives than we realize. So he said application is personal, social, and global. We have global trade, even socializing. How, our psychology changes when we have a best friend or one or two, and then 5 more come into the picture. We actually change with the amount of people and the influence of the people. Personal, when we have kids in here, I say, of course they're all on social media. The computer is zeros and ones. It's all math. Inspiration, there's beauty in nature, art, and literature. There is rhythm. In fact, the Bible has that poetry and the rhythm. It uses the alphabet, the Hebrew alphabet, and there's a lot of parts that are poetic. So does God use math's music to inspire and instruct? Because now that we've established math is in music, here's Deuteronomy. This would be Moses' farewell speech, and he says, what God told him, now therefore write down the song for yourselves and teach it to the children of Israel. Put it in their mouths, that this song may be a witness for me against the children of Israel. If you've ever read the song of God, it's heartbreaking. If it was in today's music, it would be a country western song, right? Because it's so sad. You're going to leave me. You're going to be unfaithful. So here we have it again. The people shouted when the priest blew the trumpets. Here's the instruments giving off that sound. And this is going to be victory. And here, I love this, King Jehoshaphat. When he had consulted with the people, he appointed those who should sing to the Lord and who should praise the beauty of holiness, the math of holiness, as they went out before the army. Can you imagine if Russia had tanks all lined up and another army was marching and they have a choir in front of their army? Wouldn't that throw everybody, right? But there's a reason. King David, the shepherd king, was a type of Christ. His psalm songs speak for us and to us even today. About midnight, Paul and Silas were praying and singing hymns to God, and the other prisoners were listening to them. So the math and music inspires, encourages, and strengthens us. So what do today's mathematicians say about math? Okay, we're just going to look at this, and then we're going to apply it. Okay, here's that Marcus de Sautoy, I was telling you, professor of math at Oxford. He did a BBC documentary in 2008 called The Story of Math. It's excellent. We've watched it. It's several episodes because he starts with the earliest known places where math began. I'm sure it was Egypt and Babylon. He goes through all of them, but you see the cultures, and he shows how they were doing the trading and buying and what they used. One of them used, some of them just used like stones. You know, it's just so interesting how humans were learning to count. And he calls mathematics the language the universe is written in. He says it's a language. Okay, here's Dr. Randy Pawlowski, who's an award-winning teacher, math teacher in 2014. He said math is a human language because it allows people to communicate with each other. It transcends borders, right? If I don't speak your language, we can still understand math. We can all understand it. So here's people saying it's a language. And I love this guy. Eugene Wigner, he called the laws of nature in another quote, it's a miracle and a gift we don't deserve. And he was blasted by his atheist friends because you're not supposed to put miracle because that brings in the supernatural. But he said it like it is, so I respect this man. He said, the laws of nature must have been formulated in the language of mathematics to be an object for the use of applied mathematics. So he's saying the laws of nature are formulated within this language of math. That's a lot, because we obey the laws of nature. Okay, so here's language. According to the dictionary, it's a systematic means of communicating ideas or feelings by the use of conventionalized signs, sounds, gestures, or marks with understood meanings. The key is meaning. Without meaning, words are just ink on paper, chemistry on matter, right? Here's Philip Lieberman. He said, speech is so essential, so language is so essential to our concept of intelligence that its possession is equated with being human. So it's a human mind that is associated with language. And I love this. This is, I know, Noam Chomsky. So in, I think it was 1950s, there was a deaf school in Nicaragua, and there were 400 students. And until Noam Chomsky, and he was, linguistics was his master. But he recognized, up until probably the 60s, it was believed that children could speak because they were hearing their parents speak to them. Well, then when they saw this deaf school of kids that could not lip read, had, unbeknownst to their teachers in their village, so their parents, they would all get together and create their own language with, signing, but it was their own sign language. And so how does that fit into they only learn what they hear? So Noam Chomsky said, the innate ability of children to acquire the grammar necessary for a language can be explained only if one assumes that all grammars are variations of a single generic universal grammar, and that all human brains come with a built-in language organ that contains this language blueprint. He's saying it's actually innate in us, that we will seek to communicate whatever way we can. We have a language gene, and we now know he was absolutely correct. So that changed everything of how we look at communication. So in summary, experts call mathematics a language. Intelligence is essential to produce language. Our ability to learn language infers a built-in language blueprint. Does Scripture offer any clues? In the beginning was the Word, and the Word was with God, and the Word was God. That word is logos, and it's the spoken word with meaning and motive. See, we have that within us. There's our innate desire to speak with the Creator. The unfolding of your words gives light, it gives understanding to the simple. So there's that meaning, and then it teaches me how to understand you, Lord. For who has known the mind of the Lord that he may instruct him? But we have the mind of Christ, and therefore we understand his language, and we get to know him. The fact that he wants us to know him is amazing. When you look at other cultures with their gods, the Greeks and Romans had the gods on Mount Olympus, and they were far away. And in India today, you have to feed the rats and the cows, because they're reincarnated. And it's always that humans are building their bridge to their gods, but our God built a bridge to us with his son's death. For me, there's no comparison. So let's do the math. Okay, prime numbers are the building blocks of all numbers because every number is built by multiplying primes together, and yet prime numbers can only be divided by 1 in themselves. And it says the pattern behind primes has yet to be uncovered. And this is in 2010, and this is the mathematics professor at Oxford. They still don't know. They still don't understand how that works. So how did we invent it if we don't even understand it? Okay, and here's connecting opposite corners of squares. So start at the very smallest. You connect the corners, and it gets bigger and bigger. You create a logarithmic spiral, growing wider by 1.618, which is pi. It's called the golden ratio. And Fibonacci also used this. Here he is. The Italian mathematician developed a sequence known as the Fibonacci numbers. They appear in mathematics, computer algorithms, and nature. Each number is the sum of the two previous numbers. So there's our hand with the bones. So you add, so 2 plus the 1 is 3, and then 3 plus the 2 is 5, and then 5 plus the 3. So you see that. But it's in galaxies, especially botany, obviously anatomy. So let's look at human cells. There are 37 trillion cells in the average human body. 37 is a prime number. See, God has math in places that we wouldn't even think of looking. Within our cells, the DNA molecule measures 34 by 21 angstroms at each full cycle of the double helix spiral. 34 and 21 are Fibonacci numbers. Here's information. So Gibraltar has a cave. And in the cave, this hashtag was found. And of course, no one had any doubt that a human did this, right? It looks like early tic-tac-toe. They're saying it's a primitive hashtag because is it Twitter? Which one does hashtag something? People sign off and they'll put hashtag in their name. Anyway, so of course they thought, oh wow, this is so cool. And so they have no problem saying this is human intelligence because this is language. And yet, DNA, a 3 billion letter word or number digital code, is not considered language. In biochemistry, and this is that Oxford professor, he says in biochemistry, each protein consists of a string of chemicals which are letters in a book. He's talking about the DNA. But to read this language and predict how the one-dimension string will fold up in three-dimension space, you need a mathematical dictionary. So here is a brilliant mind in mathematics saying you need help to even figure this out. And this is DNA. The complexity of DNA is amazing. Here's Andrew McIntosh. We've actually heard him speak. He's a UK mathematician. He said because no advanced thinking can be allowed, because right, the world wants to keep God out of this, there is no way nucleotides can arrange themselves in a predefined code because that assumes prior knowledge. If there's a code that's already been predefined, who did that? Who did the code? He said, so there's no way that could happen without a mind behind this. All right, so DNA's proteins, DNA's proteins were assigned to a musical scale, and you tell me if there's a pattern. All right. I've got to get here. These bifocals, I'm still learning. Okay, here's beta globin. And that's, of course, in our blood. Can you hear it? Don't hold it next. Oh. Here. Okay, that's beta globin. Now we're going to look at another one, acorian. So remember, random instruments were applied. Let's see, acorian. Here it is. Applied to the protein, some part of the DNA, just to look for patterns. Can you hear it? So we hear a pattern, don't we? So all of creation, including music and poetry, is built on mathematics, which applies to even the tiniest molecules. You can actually go to a website called Genetic Music, and they'll explain how they did that, and it's just seeing that there's a pattern in what appears to us random protein associations. So I think it's C and G are always together, and A and T are always together, and yeah, they said, and yet there's patterns. So let's look at life. The likelihood, this is Sir Fred Hoyle. He's an astronomer, a cosmologist, and a mathematician. He said the likelihood of the formation of life from inanimate matter is 1 with 40,000 zeros after it. It's enough to bury Darwin and the whole theory of evolution. It's impossible. Venus flytrap. I love carnivorous plants, and so in our house we have Venus flytrap and pitcher plants. So when there's a fly in the house, it's just a matter of time. I don't have to go chasing after it and smash it against something and then scoop it up. It's just great. It'll be going, and then we know it's taken care of. So the Venus flytrap, it has these sensitive hairs. If you can see in the bottom part, you see those little hairs sticking up. They have a built-in timer, and scientists cannot explain it. So fly lands and it touches one hair. That immediately 20-second timer begins. Not 18, not 22, 20-second timer begins. The second hair needs to be touched within the 20 seconds and it closes. And then as the fly does this, then the digestive enzymes are released and he's now being digested. But it's exactly 20 seconds. All right, here was an experiment. It used to be believed that, when plants are taking in photosynthesis, they're making starch to keep their own systems running, and they put aside starch for the night because when there's no light to photosynthesize, then that starch is what keeps them going. Keeps them going through the night. Well, these mean scientists, they had these plants in a big warehouse, and they got 12 hours of light, 12 hours of darkness, and they're measuring, and everything's going perfectly. Well, then one day they said, shut the lights off 4 hours early. So they only had 8 hours of day to get the light, and they had 16-hour night to get through, based on the starch they had set aside that 8-hour day. Because by the time dawn begins, plants have used up 95% of their starch. They don't hold on to it. It's used throughout the night. So they're like, yeah, let's see what they do. They adjusted immediately to the shock of the scientists. And here's why. They said these dynamics would require an arithmetic division computation between the starch content and expected time to dawn. So when they're using it, there's this something inside of them that tells them use it at this pace because the dawn will be starting at, within this amount of time. It says we introduced 2 novel chemical kinetic models capable of implementing analog arithmetic division. So in other words, the plants are doing math. So I really have no excuse. Brainless plants can do the math. So, yep, I told Roger, I said, I'm going to start doing the math. Here's slime mold. I love slime mold. I was fascinated. There was a man, he was the expert in slime mold. I think he's recently passed away. And you'd think, wow, you spent your entire 40, 50 years of your career studying slime mold. But so I looked at it, and I can't believe how fascinating it is. So it's actually an amoeba. There's, I think, 3 different kinds. But they are masters. Remember, no brain, no eyes, no ears, nothing. It's just a slime. It's just an amoeba. They can actually do mazes quickly. So their reward is oats. They love oats. They actually eat healthier than most of us. And so that's the slime mold at the top, and there's a piece of oat at the middle. And you'll see that once it starts a certain, if it goes a certain way and it's a dead end, it immediately stops and then goes around. It just is very quick. And of course, it's not moving this fast. This took hours. But they will find the most efficient way. So somebody thought, well, hey, let's look at transportation. Let's take the hub. This is Tokyo. Look on the left, Tokyo. And there's a slime mold beginning to fan out. And this person, engineer, he put oats where the cities were that were serviced by the train coming from Tokyo. And so within 16 hours, you could see the slime mold had found efficient ways to each of those cities. So then he compared it. So look on the left, the 2 on the left, up and down. So the slime mold network is the one on the top on the left, and the real Tokyo network is below it. And then on the other side is London. So look how similar. And they spent millions in Tokyo. They could have just put some oats, and in 24 hours would have had a place to start. Think of the money that would save city planners. Okay, so this work provides a fascinating, convincing example that biologically inspired pure mathematical models. They're recognizing that living creatures are using pure mathematics, can lead to completely new, highly efficient algorithms able to provide technical systems with essential features of living systems. what's happening, it's called biomimetics. It's a branch of science that's just exploding. We are using nature now, whether you believe that it's created or not, but there's an acknowledgement that nature has better systems, better logic. They have better joints. They have unique things we've never seen before. Last night I was telling them that geckos have self-cleaning feet. So now they're thinking of trying to figure out how that is done, and can we apply it to adhesives and bandages for hospital patients. There's a shrimp that has something with its eyes, and we're looking at optical coating for human eyes. I mean, they're just seeing that these things are done better. Of course, we know why, because it's by a superior being. Okay, here's insects. From a mathematical and engineering perspective, hexagons are one of the best shapes for construction. Now, these are seen through a micron microscope, so we're seeing them through the microscope. So these are butterfly eggs. But look at the hexagon shape. Okay, Australian stingless bees store their honey and brood cells in a golden ratio spiral comb. Now here's the flying math. Bees solve the traveling salesman dilemma. The traveling salesman dilemma, of course, is if I'm the salesperson and I have 5 cities to get to, what is the most efficient way for me to get to each of those cities? And it really is. I mean, we have computers now that can do it, but before computers, you had to figure it out yourself with a map. Well, they want to see, bees are one of those. They have to visit a lot of flowers. So what they did is in the fall, this was done in England, in the fall they attached these little transponders to the bee, and they had 5 nectar stations. And in the fall, nectar is scarce, so they want to motivate the bees to visit all 5 in a specific way, and so each one had a 1/5 of the nectar they could carry. So that would motivate them to go to all 5 stations. So by the 5th one, they would have the maximum they could carry, and they would then take it back to the hive. So were they in for a surprise? It shows that bumblebees with their diminutive 1 milligram brain, which is the size of a grass seed, are capable of finding nearly a perfect solution with relatively few attempts. There were 120 possibilities, they did it in 20, and in a relatively short time. So when animals make some amazing revelation, we then have a press conference, and here it is. Before this study, such sophisticated learning was thought to be something only larger brain animals were capable of. And this is the University of London. They were wowed by the bees. All right, cicadas. They're equipped with not only a timer, but a thermometer. Has anybody heard cicadas? I know they're really, okay, you have. Yeah, it's Midwest to the East Coast. And depending on where they are, a completely different sound. In Nebraska, where Roger, he's in southwest Nebraska, it's a wow, wow, wow. And you go even to eastern Nebraska, and it's a high-pitched buzz. We've heard them in Virginia, West Virginia. Yeah, very different sounds. So what they do, they're kind of God's pruners, because they lay their eggs are in the ground, and every 13 or 17 years they emerge, and it's just like this huge amount of bugs climbing up the tree, and they really molt their skins a lot, and so you find a lot of those molted skins. That's what we used to when we were kids. That's actually that's the actual size of them there. But 13 and 17 is what? Oh yeah, on the stage. Oh yeah, they're not that big. Sorry, they're probably that'd be like a horror movie, right? Yeah, they're like that big. That's funny. I didn't even think about that. Can you guys see real clearly with the lights on? This is okay? All right. And so when they come up and they start molting like crazy, anyways, they start chewing off the ends of the branches. So those are falling. So they're actually pruning trees. But 13 or 17 years, those are both prime numbers. So see, they're doing the math. Here's taking traffic control lessons from ants. There's an entomologist, a woman, Dr. Dusator, and she's in Sydney, and she has the best job ever. She creates little obstacle courses for ants, and she's got her little ants. She keeps them in these ant farms, and then she just, for that day, thinks, okay, I think I'll do obstacles here, and then watch them. And she's done it for years, and she's still fascinated with them. And you can watch Bugs, Nature's Little Superheroes, I think it's called. You'll see her in that. You'll see what a lot of scientists are doing. They're looking at silk replacing our plastics and being a part of bone replacement. I mean, it's amazing. So anyways, traffic control ants. Think of it. Ants move in two-way traffic patterns like people. Can you think of anything else it does? Can you imagine cows going from barn to pasture, pasture to barn? Imagine the cows all moving, and they just don't. Most animals move at the same direction, or kind of generally where they can see each other. But ants actually have set up traffic. They have a trail they follow, and they put their pheromone scent on it. And the ants follow the one with the strongest pheromone. And so they know. And so if an ant is coming along and say somebody throws a stick in front of them, they will find that way around it. And now they're leaving the pheromone of, okay, detour, go this way. And so they go really fast. But what's great, well, here, I'll show you. This is, so army ants on the top, the center lane is for going back to the nest, and the two outer lanes are going to food. Whereas leaf-cutting ants, you have ants in all three lanes going back to the nest, but the center lane is used for those going to food. So different types of ants use different traffic patterns. And here's something else. So this isn't in this, but I'm going to tell you. It's so cool. They found that there's traffic ant officers. So what ants do is they self-regulate. If the traffic starts getting congested, and the researcher, what she would do is put more food to bring more ants on this narrow bridge to see what do they do when it gets congested. They automatically slow themselves down. They self-regulate. She said because they want to cooperate. She said, humans, what do we do when we get in our car? Get out of my way, right? We don't have that attitude of cooperation. She said that's going to be the challenge. That's why they're looking at ant traffic for driverless cars. So anyways, these officers, what they'll do is if they see it getting congested, and the ants are slowing down, but it's still getting congested, they will start blocking ants coming out of the nest to make them find a different route to go around. They won't let them join the path that's starting to get full. Then they also will do so say they're going east and west, a couple of the ants will stop in the middle facing north and south, which forces the ants to go around them, and it just restructures the traffic pattern. And so it pushes them further out, and then they can move faster. It's amazing. All right, scientists tried for 8 years, and this is Dr. Dusator. She tried for 8 years to create traffic jams with ants. The humans failed. The ants kept marching. And she would throw things. Okay, so here's leafcutters. This is what she said. When opposing streams of leafcutter ants share a narrow path, they instinctively alternate flows in the most efficient way possible. Studying how ants manage this could provide the basis for a system of driverless cars, which I think is everybody's nightmare, right? Driverless cars running on ant traffic algorithms. Okay. So we're told in Proverbs, this is Solomon, the locusts have no king, yet they go forth all of them by bands. And that word bands means army ranks. Okay, it says they have no king, and yet and you can see there's a space between all of them as they're flying. But they go, so Solomon's recognizing, and remember, he was a self-taught biologist. He recognized that they all go in order, same direction, same speed. But here's what's surprising. We think of locusts as a type of grasshopper, and we think of the regular grasshopper as a different type. But it turns out the one turns into the other. So solitary desert locusts looks like our grasshoppers. They're really long-legged, and when they jump or fly, it's only a few feet. They're really weak flyers. And when something starts happening, they start congregating. It actually starts changing their color. You can see now they turn yellow and black. Their legs get shorter. Their wings get stronger. And now they can become a swarming locust. It's actually a change from one to the other. Now, the reason this is studied is because cancer cells, when they start to congregate, they will start to change, and then they will swarm into another organ. So studying swarms actually has to do with us. And we wouldn't have thought of that, would we? So here shows, so what happens is as these grasshoppers start congregating, here they are. Look at them all going the same way. They're all hopping. And these are the small ones. They all start going the same direction. And I'm going to tell you the reason why, which is a grisly reason why, but apparently this is what motivates locusts. So it says crowds of gregarious locusts will suddenly decide to march, but they do so without leaders, and these aggregations form marching bands. Do you see? This is so interesting. This is a reporter using the same words that King Solomon used. They do so without leaders and form marching bands. So here's Iain Couzin, one of the top 10 young scientists in 2010. He studies 20,000 swarming locusts in his lab. Now, think about that. a lab. It's a big room inside a building, and there's 20,000 locusts flying around. And the reporter that went to do this article was given, overalls and a mask and goggles before going in. And he says, as soon as he stepped in, locusts were smacking him against the goggles. And he saw all these scientists like, oh yeah, this is great. So they're swimming around. But here's what happened. So they have, it looks like a racetrack. It's an oval track, and it's walled. And so every day, what they do is put in 1 locust, and then 2, and then 3. And they're all like this. They wanted to find out what's the number at which they all face and start marching together. When do they go from milling around to, and there was a certain number. I don't remember what the number was, but there is a specific number. And again, like cancer cells, what is that tipping point for them? So once they did that, and they saw the number, and now they would keep putting them in until there were 2,000 of them. And the 2,000 are now marching all day. They're just marching around this oval track. At the end of the day, they start counting as they're taking them out, and there were a few missing. What? So they did it again. Count. We know exactly how many are in there. End of the day, few missing. Turns out the motive to march in the same direction is because they suddenly get this craving for protein. They will start eating you if you're a little slow. So as the locusts are marching and this guy's a little slower, take a little bite out of leg. And now the next one. And pretty soon, he just keeps disappearing, and now there's no locust. He's been eaten. And so that's why there were a few missing. I know. It's fascinating, but yeah, grisly, right? So he says, at a second critical point, the clusters would become a single marching army. Haphazard milling became rank and file. Again, using the same wording as King Solomon. Here's birds and mammals. Now, we all have seen this, but apparently in, I guess this is the UK, people actually go out to watch the murmurations of the starlings. Now, see how they go together and no collisions. What is going on? So here's Giorgio Parisi. He's a theoretical physicist with the University of Rome. He led a research team to study starlings. Findings were published at the National Academy of Sciences, and this is what he said. One bird's movement only affects its 7 closest neighbors. Why 7? It's one of those numbers that just works in nature. But it turns out, so the starlings only watch the 6 around them. So that group of 7, they just do what each other does. And of course, each of those birds is watching who's around them. And that's why it can work. It is amazing. Now, I love that. This is New Zealand. There's a new mathlete in town. That's the headline. So pigeons were taught to peck the clusters that had less in it. So they would go from less to more. So if there are 3 boxes, this one had 5, this one had 8 dots, and this one had 10 dots, they knew they had to go in the order of from less to most. Okay? So that does require doing the math. But what I love about this, so pigeons, some people call them flying rats, right? They're everywhere. They have been shown they can learn abstract rules about numbers and ability that had only been demonstrated in primates, because evolutionists believe we came from apes. And look at the reasons. They can do the math. Well, the results from the pigeons were sent to a woman researcher that did primate studies, and she said, oh, they must be studying primates. They didn't tell her it was pigeons because they didn't want her to be biased. And then they told her, those are pigeons. They both are 75% accuracy. So does that mean we come from pigeons? Because if we're going to use if we're going to say it's because of this, well, you got to throw pigeons in the mix. So here's the equiangular spiral growth. Never changes its basic shape. Here's some, so we have the bighorn sheep, I think it's the ibex and the kudu, I think. Or, yeah, I can look it up if you care. But it's just, to me, it looks like headache, right? Carrying that heavy thing. But I will tell you this, the one in the middle, the ibex, he can scratch his back so easily. He just has to just move that around. But this, it never changes its basic shape, so it keeps the center of gravity constant. Because the one in the middle, they go up and down, boulders, mountains. And you'd think that weight on their head would make them go, and then fall off a cliff. They don't. It's amazing. Okay, here's 2 elephants. Here's a piano player, and the one, of course, is joining the pianist, and he's doing this. Look at the one over here dancing to the piano music. But are they moving to the music or the math? I know, I love Here's one that has to just steal the scene. But this man, actually, he lives in, I think it's Korea, and he does this. He has all sorts of YouTubes. There was an elephant, a very old elephant, dying, and he went out and played her favorite song, and you saw her just relaxing, listening to it. They love the music. Here's cows listening to a jazz band in France. Come on in if you want. Oh, okay. So what's interesting, has anybody been around cows? I've lived, both Roger and I have lived on cattle ranches. Okay, you know. Oh, that's right, you have cows. Okay, so you know cows are mildly interested in us, but they're not fascinated with us. And so if there's a herd and a few people are standing there, a few might come over and sniff, okay, I'm going to go back to eating. But if you watch the YouTube on this, these guys set up, there's no cows. And they start playing, and all of a sudden you hear this sound. And it's the cows running to hear the music. Running. And then they all line up, and they're like this. And they just stand there the whole time they're playing the music. See, it's not cow behavior. It's the music. Isn't that beautiful? We are actually communicating with an animal that, most people eat, right? And we're communicating. It turns out they love music. Here's Juno, the beluga whale. Loved mariachi music. People would go, and it's so cute. The YouTubes are great. So he'll be at the top with the other beluga whales, and then when somebody would start playing music, he'd just drift down and go, and just suspend, just hang there listening. Loved it. So the big question, was math invented or discovered? The big answer, both evolutionists and creationists believe plants, birds, and mammals existed before humans, right? Whether you're on the creation or evolution side, the creation came first. Since these organisms demonstrate an innate ability for math, there was already math in them. Math must have been discovered, not invented by humans. And if discovered, both sides believe intelligence is required for this universal language. So here's a tale of two men. You've heard of both of them. In fact, you've read one of them. One man was from days of old, the other from modern. Ancient man obeyed God his entire life. Modern man lived as a hedonist for many years. Each would come face to face with God, and each man's response was recorded for us to read today. So here's the one, this modern man. I asked the earth, and it answered, I am not he. I asked the sea and the deeps and the creeping things that lived, and they replied, we are not your God. Seek higher than we. I asked the breezy air and the universal air with its inhabitants, they answered, I am not God. I asked the heavens, the sun, moon, and stars. Neither, say they, are we the God whom you seek. And I answered all these things. You have told me concerning my God that you are not he. Tell me something about him. And with a loud voice they exclaimed, he made us. My questioning was observing them and their beauty, their design, their engineering, their architecture, their complexity. Their math was their reply. Okay, so that's obviously Augustine. He is considered a father of the Protestant Reformation due to his teachings on salvation and grace. And Martin Luther held Augustine in high esteem and was a member of the order of the Augustinians, Eremites. So I didn't even know there was that connection. There's a whole group of people coming in. Come on in. Okay, so the last one. When Job questioned God, God pointed to his creation. What would he learn? Do you know the time when the wild mountain goats bear young? Or can you mark when the deer gives birth? Can you number the months they fulfill? Where's the math in this? We've got measurements of time, right? Time. How long for the mountain goats to bear young? So here's time, a measurement of math. Okay, have you given the horse strength? He paws in the valley and rejoices in his strength. He gallops into the clash of arms. He devours the distance with his fierceness and rage. We have speed and distance measured in math. Does the eagle soar at your command and build its nest on high? It dwells on a cliff and stays there at night. We have height. From there, and distance. From there, it looks for food. Its eyes detect it from afar. An eagle can spot a rabbit almost 2 miles away. That is like a human on a 10-story building. We're at the top, and we see an ant on the sidewalk below. That's how an eagle can see. And so 3 measurements of math. Here's Job says, I know that you can do everything, and that no purpose of yours can be withheld from you. Therefore, I have uttered what I did not understand, things too wonderful for me which I did not know. I have heard of you by the hearing of the ear, but now my eye sees you. It's through creation, through, again, the math of creation, the design, the beauty, the art. So we started with this equation, the greatest equation in the universe. 3 plus 1 equals 4. 3 nails plus 1 cross equals forgiven. 3 persons plus 1 human equals for who? You. For what? Life. For when? Eternity. And for why? Love. So Roger, I need you to come on up here. So we're now going to summarize everything we've learned about math. All the rules of math, what Galileo and Kepler and Isaac Newton and Marcus de Sautoy, so modern and early mathematicians. So I'm going to have you read what's on the... Okay, and just say it loud, honey. Unless, can you use one of these mics? Oh. It's on. Okay, math is a language requiring a mind.
For God.
Math's beauty is breathtaking and unexpected.
So loved.
Math is inclusive of all cultures.
The world.
Math reveals purpose and planning.
That he gave his only son.
Math is measurable and logical.
That whoever believed on him.
Math has tangible, absolute results.
Should not die.
Math is unaffected by time.
But have everlasting life.
How precious also are your thoughts to me, O God. How great is the sum of them. See the math in the verses. If I should count them, they would be more in number than the sand. It's saying we have so many blessings. And of course, living in our pandemic, it's hard to see the blessings. But he's saying they're there and we can't even count them. Many, O Lord, my God, are your wonderful works which you have done, and your thoughts towards us cannot be recounted to you in order. They are more than can be numbered. Praise the Lord. Let us pray. Dear Lord, thank you for this beautiful reminder of we are truly made in your image because we can understand your language, the language of math, in which the entire universe, the laws of nature, the laws of physics, they are all written in that beautiful language, and we understand it, Lord. And it applies to us in all, just much more ways than we realize. And Lord, you are a God of numbers. You count our days. You count the hairs on our head. You count when we leave you. You record our tears in a bottle, Lord. For me, this math, it just reminds me of the greatness of your love for us. So thank you for being our God. In your name, amen.